Today I have brought 4 sums for you with easy technique which are very important for your board examinations, but please don't miss any part of the video and watch it till the end, otherwise you won't be able to understand it easily. But before starting these questions, let me tell you how to identify whether the given combination of resistances in any circuit is in parallel or in series combination. Let's check it out. Suppose you have been given such kind of combination of resistances in your numerical. So how will you find out whether the resistances are connected in series or in parallel? Or similarly, if you have been given 3 resistances, resistance R1, resistance R2 and resistance R3, and now you have to join all these 3 resistances in series combination. How will you join them? What will you do? You know that this is first end of resistance R1, this is second end, this is first end of resistance R2, this is second end of resistance R2, this is first end and this is second end of resistance R3. So you simply have to join AND to AND, or that means different ANDs of resistances have to be connected in series combination. So second AND of first resistance is to be connected with first AND of second resistance, and second AND of second resistance is to be connected with first AND of third resistance. That means this combination will be like series combination of resistance. In series combination of resistances, similar amount of current is flown across each and every resistance in the combination. Suppose this is the series combination of 3 resistances in any circuit, and I amount of current is flown or supplied through this component. So what will happen? I amount will be flown across this first resistance, the similar amount of I will be flown across this second resistance, and the similar amount of I will be flown through this third resistance also, irrespective of their magnitude and values. Now let's understand the parallel combination of resistances. Suppose you have been given 3 resistances R1 resistance, and this is resistance R2, and this is resistance R3. So you have to combine or join all these 3 resistances in parallel combinations. Now this is first and second end of resistance R1, this is first and second end of resistance R2, and this is first and second end of resistance R3. So what happens in series combination? The different ands were connected, but oppositively what happens in parallel combination? Similar ands get connected. So all the one or first ands will be connected and all their second ands will be connected in parallel type of combination of resistances. Suppose this is resistance R1, this is resistance R2, and this is resistance R3. All their similar ANDs will be connected together at any point of the circuit, and similarly all their second or last ANDs will be connected at any other point of circuit. Similar ANDs are connected. This type of combination of resistances is known as parallel type of combination. Do you remember what had you learnt in series type of combination? That the current remains same in each and every resistance of combination of series combination, but it happens just reverse in parallel combination of resistances. That means if I current is supplied in this parallel combination of resistances, so I will be divided in each and every resistance, and it will not remain same. So I will be different in different components of resistances in parallel combination. But one thing is also there which remains same in this type of combination. What is that? That is voltage. So voltage or V always remains same across every resistance of parallel combination. In your board examinations, such type of questions are asked frequently, that what is the net resistance or equivalent resistance in this combination of resistance. There is different formulas for different combination of resistances. What are these formula? R net or R equivalent for series combination is equal to R1 plus R2 plus R3. If three resistances are connected in series in any question, so for finding that equivalent value, what will you do? You will simply add the magnitude or values of all these resistances, and that is in series combination of resistances. And different formula is used for parallel combination of resistances. What is that formula? What happens in parallel combination? 1 upon R net. Did you see the change? Here reciprocals of resistances are added. So 1 upon R net or 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So friends, by now you have learnt the rules and regulations of series and parallel combination of resistances in a circuit. So without wasting our time, let's come to our first question, which is very important for your board examinations. Let's start it. As you can see in this question, two terminals A and B are here, and across these two terminals different resistances are connected in different type of combinations. So first of all, what you have to do, first of all you have to find out the combination, which type of combination of resistances is here, and then after you have to solve it with the help of the formula given in the series and parallel combinations. In this question you have to find out the resistance between A and B terminals. Now what will you do in this question? You will start from here, from these two terminals, from these 2 points you will start from, and will go at the extreme end of the circuit, and will see whichever is the center point of this circuit. So where do you find the center of the circuit? Here at 2 ohm resistance. So you will start solving the question from here itself. Okay, but before doing that, let me tell you one more very important thing, that is the connection point or junction. What is this junction? Junction is a point where more than two resistances are connected. Here this point is junction point where this resistance and this resistance is connected. Similarly, at this point 2 ohm, 2 ohm and 2 ohm, three resistances are connected. So this point is junction. This point is also junction because three resistances are connected here, 2 ohm, 2 ohm and 2 ohm. Three resistances are connected. But see, this point is not junction because only two resistances are connected. And similarly, like here, this point and this point is also not junction because only two resistances are getting connected at these points. So friends, here why I am telling you about junctions. What is the significance of junctions? At junctions, the current gets divided, and wherever the current gets divided, that means there is parallel combination, and the points where the current does not get divided and it goes continuously in a continuous manner, that means there is series type of combination. So you can see that 2 ohm, 2 ohm and 2 ohm, these three resistances are in series combination because there is not any junction. Current is not getting divided. So what will be the net resistance of these three resistances? Let's check it out. We have already learned that in series type of combination, our net is equal to R1 plus R2 plus R3. So R1, R2 and R3 is 2 plus 2 plus 2. That means our net is equal to 6 ohm. So in place of these three resistances, we can join only one resistance of value 6 ohm. That is equivalent to these three separate resistances. So in place of these three resistances, we can connect only one resistance of equivalent value of 6 ohm, like that. This is the redraw of original circuit diagram. Now you can see that the resistance 6 ohm and 2 ohm are parallel with each other. How can you say that these are parallel with each other? Because these are between these two junctions. The current is getting divided here and here and here. So both these two resistances are in parallel combination. So what happens in parallel combinations? We have already learnt that reciprocals of the values are added. So 1 upon R net is equal to 1 upon R1 plus 1 upon R2. So what is R1 and R2 over here? 6 ohm and 2 ohm are parallel with each other. R1 is 2 and R2 is 6. So what will be the resultant? So our equivalent of these two resistances is 1 upon 4 upon 6. That is reciprocal. So we will have to invert it, and what will be the R resistance? R net, that will be 6 upon 4, because we have inverted 4 upon 6 and that is 6 upon 4. So in place of these two resistances, 2 and 6 ohm resistances, we can place only one resistance of value 6 upon 4 ohm. What? 6 upon 4 ohm. Now the circuit has got simpler in comparison to earlier. Now we can see that 2 ohm, 6 upon 4 ohm and 2 ohm, all these three resistances are in series combination. How are these series combination? Because current is not getting divided at any point anywhere. So all these three resistances are in series combination. So now we will find the equivalent resistance of these three resistances. And what happens? The equivalent resistance in series combination, R net is equal to R1 plus R2 plus R3. So R1 is 2 plus 6 upon 4 plus 2. 2 plus 6 upon 4 plus 2. Now we will get its resultant. So the resultant of these three series combination resistances is 2 ohm plus 6 by 4 ohm plus 2 ohm is equal to 22 by 4 ohm. So R net is equal to 22 by 4 ohm. So in place of all these three resistances, we can place only one resistance of value 22 by 4 ohm. Is 22 by 4 ohm. Now you can see that both of these resistances, that means 2 ohm and 22 by 4 ohm, both of these resistances are in parallel. How are these in parallel combination? Because junction is over here. So current starts from here, it goes here and it goes here. So it gets divided at two roots. So both of these resistances are parallel. So resultant or equivalent resistance of these two resistances will be 1 upon R net is equal to 1 upon R1 plus 1 upon R2. Why we have taken parallel combination formula? Because both of these two resistances are in parallel combination. So 1 upon R1 is what? 2. 1 upon 2 is plus 1 upon R2. What is R2? That is 22 by 22 upon 4. That means by inverting it, what will happen? It will be 4 upon 22. So what will be the equivalent resistance? Let's calculate. The reciprocal value of resistances is 15 by 22, and what will be the R net? R net will be 1 upon 15 by 22. The resistance value will be 22 by 15. So what is the value of these two resistances in parallel? The equivalent value, that is 22 by 15. Now in place of these two resistances, we will place only one resistance, equivalent resistance of value 22 by 15. That is 22 by 15 ohm. So now you can see that the circuit has been simplified very much, and it has come into series combination, and these two resistances now are in series combination. So what will we do? We will add them. R net is equal to R1 plus R2, and that will be what? 2 ohm plus 22 by 15, and now we will calculate. So the value of equivalent resistance or net resistance of these two resistances is what? 52 by 15 ohm. Or in simpler terms or simpler value, it will be 3.46 ohm. How easy is that? You simply have to do every sum step by step, and then after it will be easier for you to solve it.